Let's start the third video on the notes for Mrs. Hataway's IPC classes. I'm on page 11 in your packet. We finished question number 13, and we need to start on question number 11 in your packet. So take a minute, get your stuff out, take out your periodic table. You need to have that to work with too. And we're going to look down here at question number 11, or statement number 11. The numbers are a little wonky here, but I think we can follow pretty easily still. So down here right below the periodic table number 11, the valence electrons are extremely important in determining how reactive an element is. Metals are on the left side and center of the periodic table, while the non-metals are on the far right-hand side. And if you've colored your periodic table, which you should have, your periodic table, the vast majority of things on the periodic table are metals. These guys right here are non-metals, and then little hydrogen is a little freak over here. It's on the wrong side over here, but it's a non-metal too. And you know that because hydrogen is a gas at room temperature. If they're gases at room temperature, they're not metals. Metals, one of the things about the metals is that the vast majority of them are solids at room temperature, with the exception of a little weirdo, and that's mercury down here, and it's just kind of strange. Metals are blank, 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 and conductors of heat. So metals are ductile. Ductile means that they can be pulled into thin wires. So thin wires. They are malleable, which means they can be hammered into sheets. And they are good conductors of heat and electricity. So they're malleable, they're ductile, they're conductors of heat and electricity. They have a high density. And let's see, ductile, malleable, we could say tensile strength. I don't know, maybe we'll get to what the other blank was here in just a minute here. Non-metals are the opposite. They are, here we go. How about shiny? Let's put shiny up there. So they're ductile, they're malleable, they're good conductors of heat and electricity, they're shiny, and they have high density. Non-metals are the opposite. They are dull in appearance. They're not going to look shiny or anything like that. They are brittle. Brittle means they break easily. And they are poor conductors of heat and electricity. And they have typically a low density. Low density means that there are not a lot of atoms packed into a small amount of volume. Metalloids have properties somewhere in the middle. That means they have properties of both. A lot of times what we do with the metalloids, and here are the metalloids right here, typically when we talk about them, if they're on the right-hand side with the non-metals, we kind of treat them more like non-metals. If they're on the left-hand side with the metals, we treat them more or less like metals. The coolest thing about them is their decent ability to conduct electricity, which is interesting really, without getting too hot. Right here, this is something that you've heard of before, silicon. We talked about Silicon Valley in California. They used that in computers. And so it can be a really great conductor of heat, of electricity without getting tremendously hot. Let's see, blank, blank, blank is a picture representation of an element and its valence electrons. Let's see if we've got it on the other side. I bet. A Lewis dot model is a picture representation of an element and its valence electrons. Lewis dot models are really easy to draw. So they're crazy easy to draw. So let me show you an example of one. I'm going to fold my periodic table like this. So hydrogen has one valence electron. Everybody in this group has one valence electron. We talked about that. So here's the symbol for hydrogen. Oh, you can't even see that. There's the symbol for hydrogen. It has one valence electron. There it is. So when you do the Lewis valence electron dot model, what you do is you have the element, and I'm just going to put X here for, just a generic element. There are two spots open on each side, two spots open on top, and 2 spots open on bottom. So you can fit a total of 8 electrons around here, and they show the valence electron. So hydrogen has 1 dot beside it. Helium, remember helium, all these guys, if you cover up the 1, they have 8 valence electrons, with the exception of helium. Helium is too stinking small to have 8 valence electrons. It doesn't even have 8 electrons total. It only has 2 electrons. So hydrogen and helium both don't obey that octet rule where it's the magic number 8. Everything is stable with 8. Hydrogen, helium, and a couple of others are so tiny that they're stable with 2. So if we were going to draw the electron dot model, the Lewis dot model for helium, we would write the symbol, and look, there they are. If we were going to do lithium, we would do 1, and if we look at this, lithium is in group 1. There it is, group 1. We're done. If we did sodium, well, the sodium, we put the metal, the symbol for the metal, and then it's got 1 valence electron. Bam, we get 1. That's it. No deep, dark secrets here. Blank are more than 1 atom chemically bonded together. Example, nitrogen is N2, and that's a molecule of nitrogen. So let's see, we're going to have molecules. Molecules are more than 1 atom chemically bonded together. They can be the same type of atom, or they can be different atoms. Like here we have nitrogen is N2, that's a molecule. We can also have, if I can spell molecules, that's pitiful, isn't it? M-O-L-E-C-U-L-E-S. So we can have a molecule of nitrogen. We can also have a molecule of water. Notice we have 2 different elements here. So molecules can be the same atoms bonded together, same types of atoms bonded together, or they can be different ones. Blank are 2 or more blank atoms combined together, like, okay, compounds are 2 or more different atoms. Different atoms bonded together. Alright, so here's the difference between them. Molecules are typically the smallest part of it. So when you have a molecule in a compound, the compound is like the big thing up here. You can have a compound, and the compound can be, it's got to be 2 or more different atoms. So it can't be N2, O2, H2. It's got to be the same. It's got to be 2 different elements that are bonded together. So compounds have to have that word different in them. Molecules can be the same or different. And we typically, when we talk about a molecule, we're talking about the smallest part of a compound. So it can have 2 different definitions that are still linked together. So smallest part of a compound, and I'm going to abbreviate compound, CMPD. But it doesn't have to be a compound. It can also be those diatomic molecules, those elements on the periodic table that are always, when they're in their pure form, they're always bonded together. Those are called diatomics. So when we look at these, we have a compound. It's 2 or more different atoms bonded together. When we talk about the molecule, it doesn't have to be different. Compounds have to be different atoms. So if we look at this, this is a compound. It's also a molecule of water. This is a compound. It's also a molecule of glucose. This is not a compound, but it's still a molecule. So compound and molecule, just a molecule. Okay? Let's flip to the next page. On this page, and this is what you're going to do with the rest of the class period, what you have on these pages, I love these pages, what you have on the front side is information. Typically on the top and on the front you have information. Now this page is a little bit different because it has information just on the top half, and then the bottom half asks you questions. So atoms, molecules, and compounds. It's a little bit, there's some pieces up in here too. I think this is just a little bit changed up a little bit. So you have information here, you have information in your notes, and you need to answer the questions on these pages. So you have several pieces of information. So if I look down here at the very bottom down here, it says atom, molecule, or compound. Is this an atom? No. It's made of 2 different things here. Is it a compound? Yes, so it's a compound. Can it also be considered a molecule? Yes, it's also considered a molecule of sodium chloride. Now, they have another name for it since this is an ionic compound, but we won't get into that yet. Is this one atom? No. Is this a compound? Well, is it two or more different elements bonded together? No. So this has got to be just a molecule. If you flip it to the back, again, you have some information up here, but then you're going to answer some questions. Here we have these questions that you're going to answer. When you answer this stuff down here on the bottom, please don't like, do lines like this crap right here. Just write the letter out to the side. Just put a little line here and write the letter out to the side of these. Okay? That way it makes it a lot easier to grade. Same way over here, just put your letters, write them out to the sides here, so it's easier to grade. Alright? You guys have a good day.